Okay, for the finals, we will be having probability distribution. So this is part 1. This is a series of lecture about probability distribution. We have actually three parts. So let's define probability distribution. It's a formula or a table listing of all possible values that a random variable can take on. This is the theoretical counterpart of frequency distribution. So in frequency distribution, we have had the tallying part and then computing of the mean, the median, the mode, etc. While for probability distribution, instead of the tallying and the frequency, we have the probability. So there are two classifications that we are going to discuss in probability distribution, the discrete and the continuous. So in this slide, you will see the definitions of discrete and continuous random variables, but you just have to remember that for discrete random variables, these are counting numbers. Counting, and then they have an end. They are finite. For continuous, you have the scale. Between 0 and 1, we have a decimal point. Between 1 and 2, we have 1.1, 1.2, 1.23. So those are the numbers that fall under the continuous scale. So let's begin with the discrete probability distribution. So the properties of the discrete probability distribution, we have f of x greater than or equal to 0, meaning there is no value that is a negative value in discrete probability. Because they are counting numbers, it's either you have a 0 or any number on the positive side of the number scale or number line. The second one, the summation of all the function of x is equal to 1. So the summation of all the probabilities in one experiment is equal to 1. Okay, we also have what we call the probability distribution, or what we call the probability mass function, or PMF, of a discrete random variable x, which is defined for every number of x by f of x is equal to the probability of the random variable equal to x, the number x. So we will have examples about this formula so that you will know how to apply them. So let's have example number 1 for the discrete probability distribution. Find the probability distribution for the number of heads that appear when a coin is tossed 3 times. So the x random variable is actually the number of heads that appear. It's actually here in the problem. And the smaller x denotes the actual or the possible number of heads that will actually appear when we toss the coin 3 times. So, posibleng wala tayong head na makuha, isa lang yung head, dalawa lang head, or lahat sila ay head. Hanggang tatlo lang ito kasi 3 times lang siya. Okay? So, ang sample space natin will contain the following points. Head, 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 o kaya head, head, tail, o kaya tail, head, head, etc. until walang head na lumitaw, tail, 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 lahat. Okay? So, all in all, this is actually 8. And if we write down the probability distribution, it's going to be in the form of a table. So, this one is for discrete. Okay? So, for continuous, yun yung discussion kanina ng definition ng probability distribution. A formula or a table. So, pag discrete table, kapag continuous, it's a formula. Okay? Now, we will list down the x's 0, 1, 2, and 3. And then, on the right side, we have the probabilities. So, ilan ang sample points doon sa sample space na walang lumitaw na head. So, from our list, ito lang yung walang lumitaw na head. Kasi ito merong isa, merong isa. So, exactly walang lumitaw. So, this is 1/8. Okay? Ito naman, isa lang ang lumitaw na head. Ito yung mga yon. Head, tail, 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 head, tail, and tail, tail, head. Kaya tatlo, 3/8. Ito naman, dalawang lumitaw. Ito, HHT, THH, and HTH. Tatlo din. And yung tatlong heads ang lumitaw, isang point lang ang meron tayo. Kasi isa lang siyang beses na pwedeng mangyari. Okay? So, all in all, when we add this one, according to the definition of the properties ng probability distribution, it should be equal to 1. So, this is your probability distribution or the probability mass function. Okay, let's have example number 2. What if we toss the coin 4 times? So, still, our random variable x, the number of heads that appear, and the smaller x is from 0, 1, 2, 3 to 4. Kasi ang apat na beses mo siyang itotoss, so there is a possibility that there will be a maximum of 4 heads that will actually appear. When we list down the sample space, ayan yung mga posibleng mga lilitaw, ano? And this one is the probability mass function or the probability distribution. 0, 1, 2, 3, 4, and then you will list down on this part the probabilities based on the computation or the listing method. So, if we have 0 heads, it's only one possible outcome lang siya, no? Kasi, yan lang yung walang head na lumitaw at all. So, 16 lahat ito, we have 1/16. And then, kung isa naman ang lumitaw, eto siya. 1, 2, and 3. So, and another one. Ayun, 4. So, 4/16 or 1/4. Kung dalawa naman ang lilitaw, ito, sorry. Ito siya, 1, 2, 3, 4, 5, and this one, 6. Okay? Kung tatlo naman, ito siya. So, 1, 2, 3, and no more. So, tatlo. Meron pa isa, 4 daw siya eh. Saan yon? This one. Okay? So, tatlo. Now, kung 4 naman, ito lang yung point na yon. So, lahat yon ay total ay equal to 1. Kung hindi nag-equal to 1 dito, there's something wrong with your table. Okay, now for example number 3, let us find the probability mass function of the random variable m, which represents the number of red marbles out of 2 balls drawn at random from a box containing 5 red marbles and 6 white marbles. So, dalawang bola ang ating kukunin. Posibleng walang red marble, isa lang ang red marble, or dalawa sila na red marbles. Okay? Please take note that we use the variable m for this example. For our solution, we will be using, going back again with the combination techniques that we used before. So, kapag 0 ang red, remember this is the red, no? Kung 0 ang red, ibig sabihin lahat ay white balls. Kaya, ito yung ating 5 combination 0 times 6 combination 2/11 combination 2 or 3/11. Ito naman, kapag isa ang red, so 5 combination 1, 6 combination 1, isang red, isang white. Ito naman, kung dalawa yung red, ibig sabihin, dalawang red, 0 ang white. So, we have 3/11, 6/11, and 2/11, and it should be equal to 1. Okay? So, habang dumadami yung draw natin, humahaba yung ating table. Yung row niya, dumadagdag. For this section, we will discuss now the cumulative functions of discrete random variables. Pag sinabi natin cumulative, it is direct translation ng sum or inad natin lahat from the very beginning. Okay? So, ang ating function of x is equal to the probability where x is less than or equal to x, equal to summation of f of u, where u is greater than or less than or equal to x. So, we will draw the understanding of this once we discuss the examples. Kasi itong mga to are just notations, so we will follow them accordingly and it will bring light, itong discussion natin, may enlighten kayo pagdating sa examples. Okay? So, example natin, yung last natin na marbles sa box, we are asked to find the cumulative distribution function or the CDF of the random variable m, which represents the number of red marbles out of the 2 balls drawn at random from a box containing 5 red marbles and 6 white marbles. So, ganito ang mangyayari. Kapag big letter F tayo is for the cumulative, no? Ibig sabihin, we should add from 0, from the moment that we have a possibility na walang lilitaw na red marble. Palagi yon. Okay? So, kung ang F natin na malaki, F of 0, is equal siya sa probability kung ang ating random variable ay less than or equal to 0. Okay? So, ibig sabihin, since wala namang negative na part, no, yung ating probability, lagi tayo nag-start sa probability of 0, isa lang ang laman ng ating malaking F of O or F of 0. So, that will mean that it is equal to the F of O, which is 3 over 11. You go back to the previous discussion of this, kasi yung mga values nito ay yun ang sinolve natin kanina. Ito naman ay F of 1, ibig sabihin, no, malaking F, less than or equal to 1. Eh, meron tayong probability of 0. So, isasama natin yon, F of 0 plus F of 1, which is 9 over 11. Okay? And then, for our F of 2 na malaki, sabi niya, less than or equal to 2, magsisimula ulit tayo dun sa 0, 1, hanggang 2. Kaya tatlo yung laman nito. Palaging nakasali yung possibility of not drawing red marbles. Okay? So, sa dulo, dapat mag-equal yan sa 1. Kasi lahat na yan, i-add natin siya. Now, in probability distribution, we can also solve for the mean and the variance. Okay? So, ito ang general formula. So, these are only notations. So, you can assign any letter for the variable. So, for our example, dun sa red marbles natin, M ang ginamit natin at saka F of M. So, to find the mean, all you have to do is get the product. So, this time, dahil M yung ginamit natin, magiging M, F of M. So, paano yun kukunin? All you have to do is multiply and get yung nandito sa third column. Okay? So, this one, multiply. Inassign ko na lang siyang decimals para mas makita natin yung percentage as probabilities. Okay? So, when you get the summation, this will represent your mean. And for the variance, sa fourth column, ito yun, kukunin natin yung summation ng x square f of x, this time using m as our variable, m square, times f of m. So, etong mga to nakuha by squaring muna yung m and then multiplying it sa f of m. So, I think you have the idea now how to get yung mga ganitong per row na computations dahil dun sa ating nakaraan na discussion sa frequency distribution. Okay? So, when we add this one, this value is actually your summation of x square f of x. Or for that matter, we have summation of m square f of m. Okay? So, para makuha natin yung variance, we still have to subtract yung mean. So, ang mean natin ay 91 square. Okay? Now, let's focus sa discrete probability distribution. Okay? Ang waveform or graph ng isang discrete probability distribution is, as you can see in the figure. Ano lang siya, rectangle siya, at saka uniform yung distribution niya. Okay? Kasi this will help you sa solution kung alam ninyo yung itsura ng inyong mga graph. Okay? So, for continuous probability distribution, meron tayong tinatawag na normal curve. This is what we call the normal curve. We will give focus to this sa part 3 ng ating discussion. For now, no, discrete muna tayo. So, itong normal curve, makikita ninyo, meron siyang shaded area, no? Actually, yung shaded area na yan is actually the probability that an event will occur. Now, we have the discrete probability distribution muna. We have 5 different classifications of discrete probability distribution: the binomial, Poisson, hypergeometric, Poisson distribution as a limiting form of the binomial, and the negative binomial distribution. Okay? Before we go to the actual computation, I want you to understand how to identify problems kung ito ba ay binomial, ito ay Poisson, hypergeometric, etc., etc. Let's have the first one. Okay? This example is a hypergeometric distribution. Okay? Kapag diniscuss natin yung kanyang given, among the 20 new computer machines ordered by a school, 3 are defective. If 5 of these computer machines are randomly selected for inspection, what is the probability that 2 defectives are included, all 3 defectives are included? If you will notice this problem, this is very similar. Actually, it is a combination problem. Meron tayong 20 computers. Okay? 20 computers. Tatlo ang defective. So, tatlong defective, meaning we have 17 non-defective computers. And then we are randomly getting 5 of these computers. If you notice, this is similar, no? This is very familiar to you because we have used this box method sa combination techniques. If the problem is like that, then it is a hypergeometric distribution. We will deal with the computations later para lang meron tayong idea. Bago tayo mag-solve, alam na natin yung i-apply nating distribution. The next one is an example of a negative binomial. If you will look at the wordings, we have find the probability that a person flipping a coin gets the 4th head on the 8th flip, the 2nd head on the 4th flip. So, meron kang, dalawang dinidiscuss na order, no? Meron kang 4th head at yung 4th head na yon ay pang-8 mo na siyang flip. So, nag-flip ka ng una, siguro nakakuha ka ng head. Nag-flip ka ng pangalawa, walang head. Pangatlo, so hanggang sa 8 na pag-flip mo, 4 na yung head na nakuha mo dun sa pag-flip na yon. So, if this is the way that a problem is written, you should be able to identify this as the negative binomial. The next one is a binomial distribution. Okay? Ang binomial distribution, makikita mo pa lang yung problem. The probability that a patient recovers from a rare blood disease is 0.4. So, kapag ang P natin ay nag-recover, meron kang 0.4, meaning, kapag meron kang Q, or yung baliktad ng P, no, eto yung mga namatay or died, they died. No, ito yung mga nag-recovered. So, meaning, we have 0.6. Kasi this is, yung Q natin is actually 1 minus P or 100% minus yung P. Kapag ganyan, this is a binomial distribution. Okay? Pag meron kang P, meron kang Q, ayan. Tapos meron kang 15 people yung tinest, ang 15 natin is actually yung N. Kung ilan yung sample na kasali. So, ilan yung nag-recover kung 0.4, no, yung probability nun, ilan yung sa 15 na yon, etc. The next one is a Poisson distribution. Kapag nakakita kayo ng rate of whatever, no? Ayan, no? 3 traffic accidents per month. O kaya, ang konsumo sa kuryente ay 5,000 per year. Yung, meron kang word na per. Okay? Kung minsan, hindi siya straightforward na nakalagay na per, but as you go along and read, makikita mo meron kang rate na tinitignan. Yung mga yon are Poisson distribution. Okay? And the Poisson distribution as a limiting factor of binomial distribution, posible din yon, ano? Kasi kung babasahin natin itong problem, circuit boards used in the manufacture of VCDs are proof tested. The probability, so meron kang probability ng failure. Okay, failure to pero probability 0.01. Okay? So meaning, ang Q natin dito is yung 1 minus 0.01 natin. No? And then, ang N natin ay yung 200. Ayan. So, actually, kung babalikan natin yung way natin ng pag-determine ng binomial distribution, this is actually a binomial distribution, this problem. Ang problema lang dito, no, ang ating N ay masyadong malaki. Ang ating ideal na N ay hanggang 20 lang. No, you will understand this more as we have to solve this later. Ang N natin na kaya nating isolve ng hindi tayo masyadong na matatagalan ay 20. Pwede na yon. Ito kasi 200. Ibig sabihin, titignan natin yung 200 na diodes na yon. It's too much. Okay? It's too much. And then for the probability, it is very small for the probability. No? 1%. So, this is a Poisson distribution as a limiting factor of binomial. Makikita ninyo sa problem yan. Kapag ang P ay sobrang liit, kasi ang P natin kailangan 0.1, 0.05. Okay pa Malit. Malit pa din, pero 0.1 is the minimum, no? 0.1. Dapat 0.1 or yung N natin ay nasa 20 lang. You will see why I am talking about this one. Okay? So, kapag ganyan, we have a Poisson distribution as a limiting factor of binomial distribution. How to solve that, we will discuss that later on. That's our introduction for the probability distribution. If you are through with this one, you may proceed with the next video. If you need to go back to this lecture, please do so at mag-lecture kayo, no? And you may also ask me if you have confusion with regard to the determination of the classification of discrete probability distribution.